Oh, good morning, everyone. I think most of you know me, seen me, heard my name, obviously ex-Civil Aviation Authority. I'm now at Ntsu Aviation. Myself and Sam Twala opened up Ntsu Aviation in partnership with Filippo with Africa USC. So now we've got UTM. I suppose BVLOS is going to sound simple and easy to implement, so let's see how we can do this. My presentation is obviously more based on South Africa, BVLOS operations, and looking at it practically. So first of all, let's start off with what is BVLOS. So if we look at the ICAO manual document 10019, which we mentioned a few times yesterday, definition is when neither the remote pilot nor observer or observers can maintain direct, unaided visual contact with the aircraft, the operations are considered BVLOS. We then take CAA Part 101, where we define beyond visual line of sight as an operation in which the remote pilot cannot maintain direct, unaided visual contact with a remotely piloted aircraft to manage its flight and meet separation and collision avoidance responsibilities visually. So let's go back and say, when is an operation BVLOS? Go back to basics, looking at visual line of sight as defined in Part 101. Operation below 400 foot above ground level in which the remote pilot maintains direct and unaided visual contact with the aircraft at a distance not exceeding 500 meters. Critically as unaided, and you need to see the aircraft. So, when is an aircraft operation BVLOS? Is it at 300 meters, 501 meters, 3 kilometers, 400, 4,000 kilometers? Basically, if the aircraft is further than 500 meters from the remote pilot, or if the remote pilot cannot see the aircraft, and there's no observer maintaining visual contact with the aircraft, the operations are beyond visual line of sight. So we look at regulatory requirements. This is slightly more on the boring side, but we'll get to the exciting stuff shortly. So as per Civil Aviation Regulations, Part 5.11, basically need an ROC and to be approved by the director in your ops manual to fly under BVLOS conditions. The director may approve BVLOS provided you meet the requirements as prescribed in the technical standards. And an approved BVLOS operation may only be conducted in VMC and below 400 foot, unless otherwise approved by the director. So if we look at this, there are numerous options for you to become BVLOS compliant and be approved by CAA. So if we just look briefly at the requirements from the technical standards, first of all, the operator shall demonstrate compliance with the following technical requirements. Number one, that the RPA will be operated using command inputs only. So when you're looking at how to comply, does your equipment enable the RPA to be operated using command inputs only? Number two, have you met the requirements as prescribed in the technical standard 101.02.2? That's your system safety for your RLA. We then go on that the RPA has the ability to remain clear from obstacles and any other hazards and can take appropriate action to execute collision avoidance from such obstacles or other aircraft where necessary. It's important to note that this ability shall be applicable for normal and loss or degraded C2 links unless the area is void of other air traffic or the operation occurs in delimited or segregated airspace or any other mitigation is in place to avoid other aircraft obstacles or hazards. So this opens it up. This makes it not easy, but it makes it less complicated for the operator to comply if you fall into some of these areas. So when you think about compliance, look at systems, GPWS or TCAS. Is the RPAS equipped with collision avoidance technology? If yes, is this technology reliable? Has this technology been tried and tested? As Mark just said, this is new equipment. Not everything's been tried. Not everything's been tested. Do we have proof it works? Have you got a flexible use of airspace through the Central Airspace Management Unit? That gives you a block of air basically that's just yours at that stage and that air traffic control will be aware of and can advise other aircraft users. Radio communications. Does the pilot let everyone else know where he is? Notification to other air operators. Your risk assessments, consider your flight path, obstacles and terrain. Your camera system, does this allow you to have good situational awareness? Does it allow you to identify obstacles, identify high terrain? And then most importantly, your return to home path. It's all very well knowing where you're going. What if something goes wrong? How will that aircraft come back? Will that aircraft come back remaining clear of obstacles and terrain? Got to look at your C2 data link frequency, which is to be used for data to make sure that's deemed appropriate by the director and that the requirements meet the standards as per the technical specifications. Again, this would be part of your RPA system safety or your RLA application. Then it comes to demonstrating all this to the CIA. Will the RPA perform all its flight tasks through control inputs whilst in flight, and that such device is not ordinarily required to be flown manually? And again, command the aircraft to follow a predetermined course or group of waypoints. This is all up to your equipment. Does your aircraft and the system allow for this operation to be done? You've then got to provide inputs to the aircraft that in the event of needing to avoid any aircraft or other obstacle, the pilot is able to interrupt or introduce commands or instructions to the aircraft such that the aircraft can be interrupted from its set course and can safely fly an alternate course or land to avoid known traffic. So can the pilot intervene in the program flight path? This obviously takes away from autonomous aircraft. What standard operating procedures are in place for such maneuver? What training is completed to ensure the flight crew are prepared for such situations? Think about your own in-house training procedures to prevent such situation from occurring. Think of proactive flight management. Let's identify this situation before it becomes an emergency. How is the exact position of the aircraft displayed to the pilot in real time on a moving map, such that the pilot will be able to make radio calls and report the position of such RPA to any aircraft in the vicinity or to the air traffic service unit providing the service or controlling such airspace? Have you got a moving map on your RPS? What procedures, again, are in place for abnormal emergency situations in the event of software failure, loss of telemetry, loss of C2 link? How does the aircraft react in the event of receiving a flight position command that conflicts with obstacles or high ground? What does your aircraft do? Does it give you a warning? Does it return to home? Does it climb? Does it descend? What software is installed for such conditions? What happens in the event of a loss or degraded C2 link? Again, this equipment is not certified. There's not a lot of, I can't say there's not a lot of research, because yesterday all we heard was research. But obviously, we don't have evidence, we don't have sufficient safety cases. It's not manned traditional aviation where we've got thousands of years of experience. So always think, what happens in an emergency? So looking from a practical consideration, as an organization, obviously, number one, you need a ROC. Part of this ROC, you need a safety management system, safety and security, quality management system, in-house training, your operations manual, your standard operating procedures. Looking at safety management, this is the core of your environment. Make sure you identify hazards, you do effective hazard, incident and accident reporting and investigation. Have a safety culture, and again, proactive safety management. Let's prevent things. Let's not wait for them to happen. Let's not wait for them to happen and react afterwards. Safety and security. Security is a huge, huge topic in RPAs at the moment, although it doesn't seem to be given the attention it deserves. What are your adequate security measures? Looking at the aircraft, your C2 link, your crew. Your crew will be on the ground, possibly in a mobile station, in the middle of anywhere. Are your crew protected? Is your pilot station protected? Again, that gets where it's more involved. Or your pilot station may be a building or a vehicle. You may not just be standing there with your small phantom remote. Quality management system. Are there processes in place and continuous oversight to ensure you're doing things right the first time? Again, let's try to do things right instead of fixing them once they go wrong. Then obviously your operations manual and your standard operating procedures. This is all documented and approved by Civil Aviation. Mustn't just be a tick box, it must be practical, it must be followed by all your personnel. We then look at your personnel, your liveware, your center of the system. You obviously have remote pilots, remote pilot assistants or center operators. Then because all BVLOS operations are under Class 3 and higher, there's a requirement for the remote maintenance technician. Then if you look at your organization again, the people that make up your organization, your accountable manager, safety manager, quality manager, responsible person aircraft, responsible person flight ops, security manager, and most importantly, often overlooked, your operations staff who hold that operation together. So if you look at qualifications, your remote pilot needs a BVLOS endorsement. Is he rated in a multi-rotor aeroplane helicopter? Needs a medical. Have you as an organization put in place minimum hour requirements, or is it just going to be competency-based with competency checks? Induction training, aviation security awareness training, dangerous goods. Now you're bringing in pilot assistants, remote maintenance technicians, sensor operators. Do you need CRM? For those unfamiliar, that's crew resource management, teaching you how to coordinate and communicate with your peers. Remote pilot assistants or center operators. As an organization, do you feel they need an RPL? Should they just have theory? Should they do practical? Are they fit for duty? Or are you overlooking their role in this operation? Competency checks, induction training, again, aviation security awareness training, dangerous goods, CRM, an optional extra, is it necessary in RPAs? Your remote maintenance technicians, they obviously need manufacturer training, they need experience. Again, they need to be inducted into your organization, have completed aviation security awareness training, dangerous goods training, and possibly, again, CRM or MRM, maintenance resource management. So looking at the actual aircraft, as I said just now, BVLOS operations, everything is class 3 and higher. So we start off with your system safety, which you need to answer items 1 to 6 in the technical requirements. You need to cover the RPA's information, performance capabilities and limitations, your emergencies and system failures, hazard assessment, and all the fail-safe features. What redundancies are on this aircraft? Is it 4 motors? Is it 6 motors? What if 2 fail? You need a user manual and a maintenance program. You then need to do a demonstration to Civil Aviation Authority. This obviously tests the RPA's capability, the remote pilot station, the flight crew competency, as well as the operator readiness. How ready are you to put this aircraft in the air, send it off, without being able to see it? Will that aircraft come back? How far are you going to go? So this is where CA look at it and say, one operator might be licensed for 2 kilometer BVLOS, another operator may be licensed for 500 kilometer BVLOS. It's such a vast concept at the moment of BVLOS. It's very difficult to give exact standards for distances. So at the moment, it's up to the operator to demonstrate their readiness and their competency to ensure this BVLOS operation can take place. Following a successful demonstration, successful paperwork submission, you'll be issued with your RPA letter of approval in class 3 or higher. So let's put this all together, the big picture of BVLOS. So I decided to use the Shell model, which is quite a popular human factors tool used in aviation. It's been used for many, many years. So if we start off with the S, the software, this comes to all your documents, everything you need, your rules, your ROC, your procedures, your SOPs, all your permissions, flight manuals, flexible use of airspace, NOTAMs, checklists. Are all these in place? We then look at the H, your hardware. This is your equipment, your aircraft, your remote pilot station. What fail-safes are there? What configuration is your aircraft in? Is it in the correct configuration for the flight? What are the capabilities of the aircraft? What's on board? What equipment have you got? Have you got a transponder? Have you got detect and avoid? What battery life have you got? Yesterday there were a few questions around batteries. How do we extend battery life? Then you look at your RPS, your station. What is the setup? What are the displays? What are the controls? Where does a pilot sit? Ergonomically, is this practical? Your remote pilot station at this stage doesn't give the pilot sensory data. He can't feel if he's pulling Gs. He can't feel if he's in turbulence. We then look at the E, the environment. Are you flying at night? Are you flying at controlled airspace? What's your flight path? Consider privacy issues, social and economic factors in the area you're flying. What's the weather like? How many other air operators are around you? Are you listening to all of them? Are you aware of their position? Again, the UTM model would come in quite nicely here. Then look at the L. There's 2 L's here. Obviously, the bottom one is liveware. That's your interaction with other people. That's your interaction with ATC, your role players, your landowners, your clients, and the air traffic. Crew. If you're in a multi-crew environment, this is where we spoke about CRM. How are they dealing with one another? What are their leadership skills? Teamwork, communication. How do we put this all together? We think about yesterday in Filippo's presentation where he mentioned the Joburg to Mumbai flight. Is there going to be a handover? What happens during that handover? Who says what? How is that handover coordinated between crew members? Is it you have control, I have control? You fit, I'm fit. What do we use to make this all happen? How do we ensure the red light is given or the green light is given for that handover to actually take place and be effective? And then lastly, let's look at the center L, which is the liveware, you as the pilot. What is your attitude? Do you know you're a pilot? Your airmanship? Do Do you feel part of aviation, or are you just an RPAS operator? Are you trained? Are you competent? Do you understand the importance of RPAS in being in the aviation environment? You've got no sensory perception, we mentioned this. Is that not that question of, ooh, if I crash, I'm going to die and kill 300 people behind me? No, you're not. You're sitting on the ground in an office. You don't know. You don't have that question. Do I really need to do this? Do I really need to push the right button? Do I really need to control this operation to save myself? Is that a different mind shift in aviation now? The pilot's no longer on board. He's no longer protecting himself and those behind him. So basically, to close off the big picture, the BVLOS operation, we need to ensure that interaction with other airspace users takes place without impacting safety or efficiency of existing flight operations.